Hello everyone, I am Dr. Raman. In this section we are going to discuss with one-dimensional heat equation problem. In one-dimensional heat equation having three type of problem. So first type, temperature at both ends 0. Second type, temperature at one end 0, other end non-zero. Third type, both ends are non-zero. So this is a three type of problem. So in this session, the first type of problem, one-dimensional heat equation with the temperature at both ends are 0. So now see the problem. In this problem directly given a equation and satisfy the boundary condition nothing but x0, xl, and then the function values are given directly. So now from this equation it's considered one dimensional heat equation, dou u by dou t equal to a square dou square u by dou x square. Now this equation, when we are solving method of separation of variable, we have some possible three solution. In this three solution, suitable solution I am writing here. This is our suitable solution. Now we consider this equation number 1. And then the boundary condition, initial condition. So the boundary condition is nothing but the u of 0 comma t 0 when x is 0 then t greater than 0. Then u of l comma t 0 when x is l and t greater than 0. Then third condition, u of x comma 0 then x when t equal to 0. Now we have this suitable solution having two constant. So now using this boundary condition to find the value of the constant a and b. Therefore, first applying condition 1. Applying condition 1 in equation 1. So what is the condition 1? X is 0. So what is the condition? The first condition, x 0. So when I am substituting x0 in a solution, so u of 0 comma t equal to a cos 0 b sin 0 then e power minus lambda square a square t. So now the left hand side value based on the boundary condition 0, then a cos 0 1, b sin 0 0. This is the e power lambda square a square t. Then what is the next? We have 0 a e power minus lambda square a square t. Now a equal to 0 because of e power minus lambda square a square t is non-zero. I will take this left hand side a equal to 0. Now I will consider this is equation number 2. Then substitute equation 2 in the previous equation 1. Then we get the value u of x comma t equal to when a 0 the term b sin lambda x e power minus lambda square a square into t. Now you consider this is a third equation and then use applying the condition 2. Applying condition 2 in the previous equation, third equation. So second condition is nothing but x equal to L. So substitute length of the rod u of L comma t equal to b sin lambda L e power minus lambda square a square into t. Now the left hand side value is 0. Therefore b sin lambda L lambda square a square t. In this term b non-zero because of the reason when I consider b 0 then it's a trivial solution because of already a also 0. Therefore this term non-zero and this term non-zero, only we have 0 sin lambda L. Now 0 I will be taking the value sin n pi 0. Therefore I am taking from the 0 to sin n pi and sin lambda L. So from this n pi equal to lambda L, then lambda equal to n pi by L. Up to this process common for all the category, that is a one dimensional wave equation, one dimensional heat equation, any type of problem up to the common process. Now we consider this is a equation, the previous equation 3, now this equation 4. Now substitute fourth equation in the previous equation 3. Therefore, u of x comma t equal to b sin n pi x by L, then e power minus lambda square n square pi square a square t by L square. Now you consider this is a equation number 5, and before that this b, we just consider this b is a common generalized value of constant. Therefore, I'll take this n from 1 to infinity bn sin n pi x by L, then e power minus n square pi square a square t by L square. This equation number 5, u of x comma t. Then applying condition 3, applying condition 3 in equation 5. So what is the condition 3? T equal to 0. T equal to 0. So when applying t0 for the previous equation 5, u of x comma 0 equal to n from 1 to infinity bn sin n pi x by L e power 0. And then the left hand side u of x comma 0 value, the third condition is given the problem x equal to n from 1 to infinity bn sin n pi x by L. Look at this. Whenever I'm looking here, this formation is nothing but half range sine series. So what is the form of half range sine series? Half range sine series is nothing but f of x equal to n from 1 to infinity bn sin n pi x by L. In half range sine series, two limits we are possibly using. One is pi 0 to pi and other one is 0 to L. So here we apply length, so I am using 0 to L. Now bn is nothing but 2 by L 0 to L f of x sin n pi x by L into dx. So this is our half range sine series. So using the formation to calculate bn. So bn is 2 by L 0 to L f of x sin n pi x by L into dx. Now this left hand side term is f of x. Therefore, substitute f of x value is nothing but x. 2 by L 0 to L x sin n pi x by L into dx. Using the formula u v dx equal to u v1 u dash v2 u double dash v3 and so on. This is the Bernoulli function to apply in this previous one. Now when I consider here u equal to x, then v equal to sin n pi x by L. So when I am doing this function differentiation, this function integration. So therefore when I am differentiating u dash, x differentiation 1, again differentiation 0. This v sin n pi x by L, when integrating minus cos n pi x by L by n pi by L. Then again the integration v2 minus sin n pi x by L divided by n pi by L. Already one n pi by L is there, so square. Now use the formula u v1 u dash v2. Then we stop because after the value u double dash from 0. So I just stop up to this term. I'm going to substitute the bn equal to 2 by L. Then the formula u v1. So u is x. v1 minus cos n pi x by L by n pi by L. This is a v1 minus u dash 1 v2 minus sin n pi x by L by n pi by L square plus 0. Now the condition is 0 to L. Now substitute upper limit and lower limit. 2 by L. When I substituted upper limit for here, minus I'm taking out, so minus L cos. When I substituted L here, where to substitute? In this places only we are going to substitute L. So when I'm substituting L, this L and this L will be cancelled, which when I'm substituting it will be cancelled. Therefore cos n pi by n pi by L. Then minus plus. When I substituted L, the term will be 0. This is the upper limit. Minus lower limit. When I substituted 0, the term 0. Then when I substituted here, the term 0. Sin 0, 0. So therefore 2 by L minus change for this L square by n pi cos n pi minus 1 power n. So this term L will be cancelled. Therefore minus 2 minus 1 power n divided by n pi. So this is a value of Bn. So now we consider this equation number. So what we considered earlier, fifth equation. So this is a sixth equation. Now substitute sixth equation into the previous equation 5. 6 in 5. Therefore u of x comma t equal to n from 1 to infinity Bn, and then sin n pi x by L, and then e power alpha square, that is a we used, so a square e power minus lambda square, so a square n square pi square t by L square. Now substitute Bn value for here, u of x comma t n from 1 to infinity minus 2 into minus 1 power n by n pi into sin n pi x by L into minus a square n square pi square t by L square. So this is your required final solution. So thank you everyone.